Hello and welcome to Lesson 9, Part A in the Online Terrestrial Navigation course. Today's lesson is on advancing a DR position by using mid-latitude sailing. Before we jump into the lesson today, I'd like to go ahead and ask you to subscribe to the channel. If you're using these videos, you're finding them useful, subscribe, go ahead and hit that like button, share it, leave us a comment. Let us know who you are, what license you're studying for. All of these things help raise the videos and the search results for YouTube. Also, watch time helps raise the search results, raise the video and the search results. So even though these videos are not necessarily designed for you to watch all the way through, if you can tolerate it playing in the background while you work the worksheet, go ahead and leave it playing. Give us some watch time. Help us out a little bit. Move it up in the search results. Help somebody else find the videos. All right, so go ahead and grab the worksheet out of the description of the video and let's get started. Okay, this lesson is not typical of the other lessons. It's not a multiple choice uh, question and answer type deal. But what it is, this is going to be a crucial step in our next lesson, calculating time of sunrise and sunset. We're going to have to advance our DR position. And we're going to do that. There's a couple different ways you can do it. You can draw it out on a maneuvering board and plot it out like that. That's perfectly acceptable. Personally, I find it easier to just do it purely mathematically with a calculator. Just punch a few numbers on a calculator and it gives you your next latitude and longitude. And this is basically a bastardized version of a mid-latitude sailing. It's not a true mid-latitude sailing, but it works for distances of less than a couple hundred miles, which all these questions will be less than a couple hundred miles. So if we're given a latitude and a longitude like we are here, and we're going to go a distance of 77 nautical miles on a course of 324 degrees, um, we're going to figure out what our new latitude and longitude is by uh, by using a calculator here. And this is how we're going to do it. We're going to take our distance and using our Texas Instrument 30XA calculator, we're going to key in the distance of 77 miles, and we're going to hit the second function key. If you look right here above the pi key, there's a XY. It's letting the calculator know you're about to give it some X and Y coordinates. If you think back to high school algebra, the graphing and all that, it's a little bit what we're doing here. You're going to hit that second function and the XY. Your calculator is going to go to 0. It's supposed to do that, so don't freak out. Then we're going to hit our course of 324 degrees. And then we're going to second function. We're going to come over here to the multiplication key. You'll see a PR right above that. That's the second function of this key. And that's changing those XY coordinates from polar coordinates to rectangular coordinates. So we've second functioned, we're gonna hit that. This number right here is gonna be our difference in latitude. Now it's pretty important that you leave that number in your calculator because we're gonna use it here in a second. If we get a positive number right here, that's going to be north latitude, and a negative number is going to be south latitude. Notice that we haven't put the addition or subtraction sign in right here because a positive number or a negative number right here has no bearing on if we add or subtract the correction. But it does let us know if it's a northerly or a southerly correction. In this case, it's a positive number, so it's a northerly correction. Now, if L1 or your first latitude and the correction have the same name, north or south, then the correction is added. If the names are different, the corrections are subtracted. In this case, the names are different. You have south for one and north for the other. So we're going to subtract this correction. Even though it's a positive number here, it's going to be subtracted here. And most of the time, if people make careless errors, this is one of the careless errors that they make. So even though it's a positive number here, we're going to subtract it right here. And again, it's important that you don't clear the calculator out. Uh, you can come back and do the arithmetic later, but we're going to save the calculator for the trigonometry, and we'll do the arithmetic by hand or do it a little bit later. All right, so leaving that same number in the calculator, we're going to come up, and we're going to hit second function, xy again, and then we're going to divide it by the cosine of the latitude. And this is how we're going to key it in, leaving that same 62 in there. Second function, xy divided by, we're going to key in the latitude, this L1 here, in the same way we've been doing it at 28.030. Second function, degrees to decimals, cosine equals. And this number right here is going to be your difference in longitude. And again, whether it's a positive number or a negative number, it has no bearing on whether we add or subtract. It has to do with the if it's a east longitude or if it's west longitude. A positive number would give us east longitude, and a negative number would give us west longitude. In this case, we have a negative number, so it's going to be west longitude over here. And with the names being different, it works just like the latitude. If the names are the same, east or west, we would add that correction. If the names are different, we're going to subtract the correction. So in this case, the names are different, so we'll subtract the correction. And at this point, if you need to clear the calculator to use it for the arithmetic, you can. And this is our new latitude and our new longitude, lat 2 and lambda 2. That's the latitude and the longitude we would be at if we use this for a starting point and we run 77 nautical miles at 324 degrees. Pretty simple once you get the hang of it, the pattern of it. It's a really short lesson here, but it will be a really crucial step in our sunrise sunset problems, which are going to be in lesson 9B. Almost have that video finished. I should have it up in a couple of days. Anyway, like I said, leave us a like and a share. Give us a comment in the comments section, um, and hope you enjoy the video. Thank you.